But so in class, we looked at graphing inequalities. And what does it mean to graph an inequality, to have that arrow, which direction does it point, and should we have an open circle or closed circle? We looked at all those different things yesterday, or in class today, I guess. We're going to be looking at solving one-step inequalities using addition, subtraction, multiplication, and division. So you've done lots of one-step problems in the past. In 6th grade, you did it. Almost all of 6th grade was one-step problems. And so it's still the same idea, except now we have an inequality instead of an equal sign. An example would be x plus 12 is less than 20. If we're solving this, we solve it in the same way as if it was an equal sign. So you can almost pretend, don't actually write that, but you can pretend it's an equal sign. If it was an equal sign, to get x all by itself, we would subtract 12 from both sides. Subtract 12, there we go. We'd have x, instead of equals 8, because 20 minus 12 is 8. Now, instead of that equal sign there, we just say that x is less than 8. And we're going to graph those solutions. Now, when I have you do graphs, I require at least 5 lines. You can certainly do more, but 5 is the bare minimum of lines. 0 does not have to be on there. 8 should be in the center. So our solution should go in the middle. We're going to fill in a couple on either side. There we go. So we got our graph. It's just a snapshot of infinity. And we're going to graph this. We're going to say, okay, x is less than 8. Well, 7 is less than 8. 6 is less than 8. And so if we put a 7 in here, that would be true. If we put a 6 in here, that would be true. So these numbers over here, down to negative infinity, would be potential solutions for x. X is less than 8. 7.99999 could be less than 8. So we do an open circle to show that 8 is not less than 8. But everything really close to 8 is less than 8. Same idea for this one. We've got d minus 5 is less than negative 7. So I add 5 to both sides. I use that inverse operation. I say that d is greater than negative 2. So again, I'm going to make my graph. I need to put at least 5 lines on my graph. Negative 2, which is the solution, goes in the middle there. And I fill in a couple on either side. Make sure your negatives are going in the correct direction. Negative 4, negative 3, negative 2, negative 1, 0. And it says d is greater than negative 2. Well, I know that 0 is greater than negative 2. I know that negative 1 is greater than negative 2. And so all the potential solutions for d are going to be on this side. They're going to be on the right side of negative 2. And it will never equal negative 2. D does not equal negative 2. It's just bigger. So we put an open circle there to show that. Solving the inequality, almost the same as solving an equation. Graphing is a little bit different. Now we're adding that graphing in. But it's very similar solving those inequalities. I'd like you to try these two on your own and then see what you get. Don't forget to graph. I'm assuming you tried it. I'm assuming you tried it on your own. You did graph it, so make sure that you graphed it. It takes a little while, longer than a couple seconds. So if you didn't pause it, you didn't do enough. Pause it, show the work, graph it on your own. That should be the correct solution and graph for the first one. And that should be the correct solution and graph for the second one. If you didn't get those solutions and the arrow and the dot and everything, make sure that you watch the linked video. Solving equations, now we're doing multiplying and dividing. So still the same idea. We've got 2.4 is less than or equal to m divided by 3. So we do that inverse operation. Opposite divide is multiply. Multiply both sides times 3. Now, you can't see me doing this, but I'm covering up the decimal. 3 times 24 is going to be 72. So 3 times 2.4, 7.2. You can always set it up as scratch work. 24, there we go, times 3 and do the multiplication. But if you can do 24 times 3 and get 72, 3 times 2.4, 7.2, less than or equal to m. And then I'm going to graph that. Now with the graphing, as long as you're going by a consistent scale, it doesn't matter what you do. If you go 7.2, 7.3, 7.4, that's fine. If you go 7.2, 8.2, 9.2, that's fine. You can go by tens. It doesn't matter as long as you have a consistent scale. I'm going to go by 0.1, so 7.3, 7.4, 7.1 and 7.0. But again, as long as you have a consistent scale there, you can go by thousands if you want. You can go 7.2, 1,000 and 7.2. That's fine, as long as you're consistent. M is less than or equal to, so it could be equal to 7.2. And if M is greater than, M is bigger than 7.2. 7.3 is greater than 7.2. 7.4 is greater than 7.2. Another example, we got 3/4 R is less than 12. Now, there are two ways to solve this. Well, there's probably lots of ways to solve it, but there are two ways that I see to solve it. One, we could say, well, that's 3/4 times R is less than 12. We could do it that way by then dividing both sides by 3/4, because the opposite of multiply is divide by 3/4. So we could work at it from there, and that would work. Some of you are going to say, well, let's just turn it into a decimal, and that's fine too. You could do 0.75 R is less than 12 and divide both sides by 0.75. What I like to do when the numbers work like this is I like to see the division first and then the multiplication. The reason I say that is if I deal with that division first, so it's divided by 4. Well, the opposite of divided by 4 is times 4. Okay, so those 4's go away. And then it's times 3. So I'm going to divide both sides by 3. Divided by 3. The reason I do that, the reason I like to do it that way, is because 12 divided by 3, that I can do in my head. 12 divided by 3 is 4. And 4 times 4 is 16. If what I just did makes sense to you, do it that way. That's because those numbers work out really well and you can do it in your head. If your mind just went, and you have no idea what I just talked about, change it into a decimal, keep it as a fraction, do it in a different way. But either way, regardless of how you do it, either by dividing by 3/4, by changing it to a decimal and dividing by 0.75, or doing times 4 to both sides first, okay, 3R is less than, I'm just going to put 12 times 4, divided by 3, divided by 3. I know that 12 divided by 3 is 4. I'm just doing this in my head. Normally I don't write it down. I would get 16 as R. So I would do all that work in my head and get that R is less than 16. I would do times 4 to both sides and divide both sides by 3. But you can certainly do it however you want to. So I'd have 16, 17, 18, 15, 14. R is less than 16. Well, 15 is less than 16, and it won't ever equal 16. Try these two on your own. Pause it, take some time, practice graphing, practice solving these two problems. I'm assuming you tried it. I'm assuming you paused it and did it on your own. Solution K greater than 6. Solution G is greater than 36 for that one. If you didn't get those right, or if you didn't have your arrows or your dots in the correct place, make sure you check the linked video. One more here. I guess one more that I'm going to do, and then you'll have to try one. Sammy has a gift card. She has already used $14 for the total value, which is $30. We got to write and solve and graph an inequality to show how much more she can spend. One of the things I'm going to highlight here, and I'd like you to go ahead and highlight the same or underline it or something, is this word right here. Write an inequality. We're not just finding the answer. I don't want to know that, oh, she could spend $16 more. No, I want you to be able to write an inequality. That's what we're really pushing for here, is being able to write that inequality. If you can get the answer, that's great. But I want you to be able to write it down as an inequality. That is more challenging. It's more difficult. And that's why I'm going to ask you to do something more difficult. Okay, so we're going to look at solving those, or writing this inequality down. She's already used $14. She can use some more. We don't know how much more she can use at this point. I know some of you already know the answer, but we're going to put an X there because we don't know in this problem yet how much more she can spend. And she has $30 that she can spend total. So we wouldn't say that she could spend more than $30. That would be wrong. She can't spend more than $30. She only has a $30 gift card. She can spend less than $30. Could she spend exactly $30? Let's see, she has a gift card, so yeah, she could spend exactly $30. So we've written the inequality. Now we're going to solve the inequality. So I would subtract 14 from both sides, and this is where some of you did this in your head and you just knew the answer. We would have $16 left. So she could spend less than or equal to $16, and then we can graph that inequality. 16, 17, 18, 15, 14, and if x is less than or equal to $16, we're going to have an inequality like that, or a graph like that. Try this one. Recommended daily allowance, RDA, of iron. So look at Sarah and her iron levels and see if you can figure out how much more she could consume without exceeding that RDA limit. Assuming you tried it, if you didn't get the right answer, if you didn't even know where to start, take a look at the final answer here. I've written the inequality, I've solved the inequality, and I've graphed the inequality. If you're not sure how to start these problems, how to start the equation, watch the linked video, and I'll explain a little bit more about setting up the problem.